Okay, so we are now on section 8. In section 8, here we're doing the following questions, Adam. Number 6, number 9, number 11. And number 11 is that diamond question that you had. And again, that's also a function question, as you'll see. Number 15 and number 16 are the questions we're doing in section 8. So let's go straight to number 6. That's the first question you had. Whoops. Here is number 6. So the graph of y equals g of x, and of course, g of x equals y. That's a universal statement. That's always true. So they're not really telling us anything, because I told you that g of x, f of x, h of t, anything in that form, the function itself is always the y, and that just confirms it. That's all. Okay, so nothing of value is given in the first equation there. Simply saying that, look at the graph. If g of k equals 1, g of k equals 1, and what does g of k mean? G of k, f of x, anything like that is always the what? The y, right? So what this really says is y equals 1 is what they're telling you, right? Y equals 1 on this graph, okay? And here is y, the y-axis, the 1 on the y-axis is up here somewhere, right? Anywhere at this height is what you're looking at on that graph. Which of the following is a possible value of k? Now this is sometimes it's hard to figure out questions like this because they're trying to be tricky, you know? When is y 1? Well, here is the height of 1. So when x is 0, right? When x is 0, y is 1. When x is negative 1, y is also 1. So I could look for answers like that, like 0 for x and negative 1 for x. They both give me a 1 for the y. But unfortunately, they don't give us those answer choices here, right? They don't give us a 0. They don't give us a negative 1. If they did, that would have been the answer. They make it a little bit harder to figure this one out, but it doesn't have to be that hard because you can always use what? You can always use the answer choices, right? We call it UTAC, use the answer choices. And so if you just go through the answer choices, like A, negative 1.5, what does that mean? What does negative 1.5 stand for? Well, they're asking for the possible value of k, right? And what is k? That is the input, which is the x coordinate, right? So these are all values of x, right? If these are all x's, let's see what that gives us. If x is negative 1.5, here is negative 1.5, right? What is y? Well, y is up here. Is y equal to 1? No. How about b? X is negative 0.5. That's right here. What is y there? Here it is. Does y equal 1? Yes, it does. So starting with the answer choices does help out in many cases, especially if you aren't able to, in that spot, that moment on this test, you're not able to think of one very specific thing they're trying to get you to think of. So there's always a way around it because this is a standardized test, and for the most part, you do have multiple choice answers, right? So the answer to number 6 is B. Moving on to number 9. Number 9, I'll tell you 2 ways to handle this. One is the general method. And the general method is really the algebraic method. But this problem, whenever you're tested, this problem on the SAT, it's always given the same exact way. They never change this, right? It's always the same exact problem, maybe a different story with different numbers, but it's the same exact thing. And they don't change it. And so it's worth memorizing, really, you know. And as a math teacher, I don't want to tell you to do that, but you know, at the same time, that's what's tested. So I will tell you both ways: the non-mathematical way, something for you to just memorize and get right every time, and also I'll tell you the math way because it's important for you to know as well, right? But for this test, I'll tell you that whenever you're given a question like this, they will never change this up in any way. A regulation for riding a certain amusement park ride requires that a child be between 30 inches and 50 inches tall. So this height, right, and I'll use h, which is good because they end up using an h in a problem anyway. The height needs to be between 30 and 50. Now, does between mean less than or equal to, or just less than, right, for these signs? It means less than because if it's in between something, it's exclusive of the endpoints. if they want the endpoints to be included, they would have to use the word inclusive. So between 30 and 50, inclusive would mean that. But they don't use the word inclusive here. So it needs to be in between, right? So h is between 30 and 50 is what the first three lines say. Which of the following inequalities, so which of these, can be used to determine whether or not a child's height h satisfies the regulation for this ride? Well, actually, this is the inequality that tells or determines whether a child can be on the ride or not, right? If your height is between 30 and 50, you can go on a ride. If it's not, if it's outside of that range, you can't go on a ride. So this is your answer. This is the correct answer. All they want you to do is take this and give it in a different form, right? So let me show you the shortcut first, and then I'll show you the math way, or the more correct way. For all of these questions, you'll always have one thing given. This is all they tell you. Through all of these words, this is the only thing they're giving you, right? And then simply they're asking you to take this and put it into this form. And when they ask you to do that, of course, you're always going to have the h there, as they do. This is always going to be a minus sign. Now, in most cases, this problem happens to have minus signs all across the board, but many times, at least two of these will be positives. So on the actual test, when you take the test, it's likely you'll be able to cancel out maybe two of the answer choices simply by knowing that that should be negative. Okay? The other part of this answer I want to memorize is this sign right here. Of course, if this says less than, that should be less than. If this is less than or equal to, less than or equal to. Okay? This one is always less than. And again, for some reason on this particular problem, they're all less thans, but on most other questions, you'll see that some of these will be either greater than or even less than or equal to, which would be wrong as well, right? So this part, just by knowing this, you should be able to eliminate many of the answer choices. Now, how do you get these two numbers? For this number, all you need to do is find the exact middle between these two. Between 30 and 50 is 40, right? So 40 goes right there. And so you look for the 40a. There it is. Nothing else says 40, so that you can cancel everything else off. D will be the correct answer for this one, right? Sometimes that's not even enough. It usually is. But if it's not, how do you get the answer? How do you get this number right here? That's simply the distance between the midpoint and either endpoint, right? I mean, it's the same distance because you're right in the middle, but the distance between, for instance, a 40 and 50 is a 10. So that number will go right there. And that's exactly what's given. So D is the correct answer to this one. How do you do this algebraically? Well, you would have to go through each answer choice. And that's the only true way to do it. But since we now know the answer, I'll just show you one example instead of showing you 5 examples of the same thing. Just one example for the right answer. What you have to do is just take the answers given, such as D in our case, and solve it out algebraically. Absolute value equations and inequalities, they always have two cases, a positive case and a negative case. The positive case here says h minus 40 is less than 10, that's a positive case, and h minus 40 is, now I have to use a negative case, which gives you a negative 10 on that side, but whenever you add a negative sign to this, what do you do with the sign? Do you remember what to do with that sign? Flip it, right? And so you solve for this, you solve for this. And as long as it matches both sides, you have the answer. If you add a 40 to both sides, you get h is less than 50. H is less than 50 is exactly what you have there. And h is greater than, if you add 40 on both sides, you get h is greater than 30. And h is bigger than 30. So D will be the correct answer for that. Unfortunately, to get this one right the right way, you have to go through A, B, C, and then do D and to see that, A, it works on both sides, and therefore that is the correct answer. So that's the mathematical way to do it, but hopefully you can memorize this question and not spend and waste that time, that precious time on this test, so that you can allot that to other problems that may need more of your attention. Okay, so that was 9. Number 11 is the next one. And here is the one on which you ask the question, what does this guy mean? They use all sorts of different symbols for questions like this. This is another function type question. But my short answer is it doesn't exist. What does it mean? You're not supposed to know. You were never taught it in school. This could be a heart. This could be an empty diamond. It could be, I don't know, 4 lines. This can be anything, right? And so because they're just making up this figure, they always define it for you in the problem. And so here it says, if k, n, and r are integers, and integers are non-decimals, it could be positive, negative, or 0, as long as they're not integers, or sorry, as long as they're not decimals, they're considered to be integers. Let k, diamond, n, comma, r, and I have no idea what this means, but be defined to be, so they define what that should mean for this problem. To be true if, only if, n is less than k is less than r, right? So that's true as long as this statement remains to be true. So let's see how we can apply that once they give us some more information. If negative 2 diamond n, comma, 0 is true. Well, when is something like this true? It's defined to be true if n is less than k is less than r, right? So normally what we have here is this, k, diamond, n, comma, r, right? This is my k, this is my n, and this is my r. And they want n to be less than k to be less than r. So what is this? N. What is the n in my case? That's just an n, okay? So I'll leave that as an n. K, where's k? K is here, right? So that's my k in this problem. And so that's a negative 2. And r, where's r? R is here. And they want the r to be a 0, right? So in order for this to be true, this needs to be true, right? So far, with the information we have so far, is this true? 0. Yes, that's bigger than a negative 2, so that is in order, right? So far that's good, as long as we have n in the right place, which means it has to be less than 2, right? Which of the following could be a possible value of n? Obviously, there are infinitely many answers that work for n. Roman numeral 1 says negative 3. If n were negative 3, does this work? Yes, it does, because negative 3 is less than a negative 2. So 1 works. So based on that, we can cross off b, and we can cross off e, because neither of them contain the answer 1, and it should. Negative 1, does that work? Negative 1 is not less than negative 2. That does not work. And so anything with a 2 in it, that doesn't work. 2 in it, we already crossed that one off. And the last one, Roman numeral 3, it says 3 is 3, positive 3 less than negative 2. It is not. So the answer is 1 only. So answer to 11 is A. Number 15 is next, so we just have 2 more questions to do. Number 15 and number 16, I can show you a very easy way to do this, so hang on tight, but we'll get to that. Number 15. Here is the graph, right? Maze completion times. So this is in time, this is number of practices. So if, there was I guess we're talking about some hamsters here, right? So it looks like what they're trying to tell us is for this number of practices, so if a hamster had 1 practice, one of the hamsters, I guess, had 1 practice, and it completed the maze in 40 seconds. Another one was given 1 practice, and that particular hamster finished the maze in 45 seconds. There was another hamster that was given 2 practices, and that one was able to finish it in a little over 40 seconds, and so forth. So that's the graph we have here. And the question says, Doug's biology experiment involved timing 12 hamsters in a maze. Each hamster received at least 1 practice before being timed. And it shows us that, right? There's nothing here for the 0. No one got 0 practices. Everyone at least got the 1, right? So no new information here. The scatter plot above shows the time each hamster took to complete the maze and the corresponding number of practices that each hamster received. And all that information was already given in the graph, so we don't really need any of this. Based on the data, okay, look at the graph, is what they're saying. Which of the following functions best models the relationship between t, the number of seconds, and p, the number of practices? So they want us to basically come up with the function that models this, that looks something like this, right? So which of the following given graphs will look like that is the question. Okay, so I'm going to have to keep going back and forth unless I make this really small for me to be able to fit everything here. So hopefully you have the test in front of you. But let's look at this real quick. We know that many of these look like lines, right? That's a line, that's a line, that's a line, that's a line. And even this is a line. They're all lines, actually, right? Because the slope here is 1 over 44, and p would be your x. So these are all lines. And if you know the form, and again, the most important form of the line is what? Y equals. We discussed this in section 2 as well. mx plus b, right? The slope-intercept, the y-intercept form, the slope-intercept form. So what do we have here? These are your y's, right? T of p, f of x. Those are always y. So y equals 44. That's just the number. That's like that, right? We don't have an x. Basically, well, we do, but it's a 0x, right? Plus a 44 is what this really says. So what is the slope in this one? It's a 0 with a y-intercept at 44. This one has a slope of 1 p, or the x, and that's the input, plus a 0. So your y-intercept is a 0. In this case, your y-intercept is a 0, slope of 44. Slope of 1 over 44, y-intercept of 0. Slope of 1, y-intercept of 44. So those are probably the best things to use for this problem. The only y-intercepts we have are 44, 0, 0, 0, 44. So is it 0 or 44, right? Let's figure that out first. That eliminates a bunch. So if you look at this graph, do you think the y-intercept is at about 44? Is it going to, whatever this line looks like, that best fits these points, will it be at 44 or will it be down here at a 0? Looks obvious, right? It's a 44. My line is over here. It's not over here, right? It doesn't try to cross the y-axis all the way down here and then, curves upward and it looks pretty level up here. And so if I were to pick a point at x equals 0, it would probably go through the 44 more than it might the 0. So 44 is probably the correct y-intercepts. And so what can I do? I can cross off the one with y-intercept of zeros. B's out, C's out, and D's out. We're stuck between E and A. This one says y equals 44, right? This one says y equals p plus 44. This one has a slope of 0. We talked about that, right? That's a 0x. This one has a slope of 1. And that is the only difference between A and E, right? The slope. Slope of 0 is a horizontal line. Slope of 1 is a increasing line from left to right, right? So which one is this? Is it pretty much a 0 or is it a slope of 1? It's closer to being pretty flat, right? You can see a point here and a point here. It's not really rising, really, is it? Right? We have a point here, we have a point here, we have a point here, point here. It's pretty much even across the board without, continuing to increase each time you go up. So it doesn't, based on this information, it really doesn't look like the more practices a hamster gets, the more time it takes, the time really doesn't change, right? So the correct answer to this one would be A, the one with a y-intercept at 44 and a slope of 0. And the last one, number 16. This is the figure. And here's a question. The pattern shown above is composed of rectangles. This pattern is used repeatedly to completely cover a rectangular region 12 L units long and 10 L units wide, right? So this huge area has these dimensions, 12 L by 10 L. And what we're doing is using this pattern right here, right? This guy right here. So these are actually smaller in relation to this huge, basically a floor that we're trying to cover with tiles that look like this, right? How many rectangles of dimension L by W are needed? L by W. What is L by W? L by W, how many of these guys are needed is the question, right? So, I know that we have this huge floor we're trying to fill with this pattern right here, right? And the dimensions, obviously I can't draw that huge floor here, so I'm just going to draw it small here. Sorry, this should be smaller and this should be bigger. But it's a 12L by 10L based on the problem, right? So these are the dimensions. So here's what I want you to do. There's an algebraic way to do this, sure. But I want you to plug in. What is the great number to plug in? If you've seen the plug-in lesson, hopefully you're able to follow the hint. I have 2 L's here. I have 3 W's here. I have a 2 and a 3. What's a great number to use when you're trying to work with 2 and 3? Whatever both go into evenly. 6. So what is 6? I'm going to say that this whole thing is 6. If that whole thing is 6, that makes each W what? A 2. And that makes each L a 3. Basically, I have a 3 by 2 rectangle. How large is this entire region? Remember, L is 3, right? So 12 times 3, that's a 36. 10 times L. 10 times L is again 3. So 10 times 3 is, this is a 30, right? So this area right here is a 36 times a 30, right? A 0, that's an 18, that's a 9, 10. So 1080 is the entire area of this big rectangle. So what they want to know is, in this huge place, how many of these L by W's fit? And what is the area of one of these? 3 times 2. 6. So how do you know how many of these 6's go into the 1080? Take out your calculator, divide. So what we have here is 1080 divided by 6, right? We need to know what 1080 divided by 6 is, right? So 6 goes into 10 one time so far, with the 4 remaining. 6 times 8 will give you exactly a 48. And nothing left over, so 180, right? So 1080 divided by 6 should give you a total of 180. So 180 is the correct answer to number 16. And so let's see where we have 180. E, therefore, will be the correct answer. To this problem.